Hello and welcome to IVA, where learning is through understanding. Today's lesson is matter and measurement. We're going to talk about classification of matter and its properties. Table of contents. Identify the characteristic properties of matter. Differentiate between the different states of matter based on their properties. Distinguish between pure substances and mixtures. Distinguish between homogeneous and heterogeneous mixtures and give examples on each, and identify elements and compounds and give examples on each. Now, remember, feel free to pause or rewind this video whenever you would like. If you haven't done so already, go ahead, pause the video and take the pre-assessment. This will capture your current level of understanding of the lesson. What is matter? Matter is anything that is made up of particles that have mass and take up space. If we look at the figure over here, we can see a macroscopic view of the beaker with the water inside it boiling. And if we zoom in, we see the microscopic view, which is the particles that we cannot see with our naked eye. Properties of matter. Let's start by recalling what a property is. A property is a characteristic that defines an entire set of substances. For example, all metals share a certain set of properties that distinguish them from other elements. Properties are used to separate substances and classify them into groups. They also help reveal the identity of an unknown substance. So if we want to list a few properties that distinguish metals from other elements, we can say that all metals have a high boiling point, high density, they're good conductors of electricity, etc. Properties could be classified as chemical or physical. Chemical properties have to do with the way substances react, such as how flammable they are, how toxic they are, how do they form their bonds, what is their oxidation state, etc. And on the other hand, physical properties are divided into two. We have extensive properties and intensive properties. Extensive properties depend on the amount of matter that we have, for example, volume, mass, energy. So we can say that if we have 1 gram of ethanol burning, this would produce less energy than 10 grams. So here we can see that mass has an effect on the property. Intensive properties do not depend on the amount of matter that we have, such as melting point, boiling point, density, etc. So if we have 1 glass of water or 1 gallon of water, the boiling point of water is still 100 degrees Celsius. The three states of matter that will be considered are solid, like ice, liquid, like water, and gas, like steam or the clouds. Now there is a fourth state of matter, which is plasma. Plasma is hot ionized gas. Usually when a gas is heated to a very, very high temperature, or when an electricity passes through a gas, it gets ionized into an equal number of positive and negative ions. The noble gases, helium, neon, argon, krypton, they're used to make neon signs by passing electricity through the gas and ionizing it into plasma. Particle motion in solids, liquids, and gases. Earth is the only planet where water can exist in the three different states. In the iceberg, it's a solid, in the sea, it's a liquid, and in the surrounding air, it is a gas. Solids have a definite shape. We can see over here a block of ice. It takes the shape of its mold or the container. As its temperature increases, it starts to melt and the water spreads out and fills the container. Well, all liquids behave this way, not only water. They flow and they find their own level. Gases spread out even more, filling any space that is available. The way solids, liquids, and gases behave give us clues about how their particles are arranged. If we look at solids, we can see that the particles are arranged in a fixed framework. They are held close together by strong intermolecular forces of attraction, and they vibrate in their place. In liquids, the particles are still in contact with less forces of attraction holding them. They're free to move around, they can slide and rotate. The particles in a gas, as we can see, are far apart, no forces of attraction, they move quickly and randomly in any direction. We have seen how matter can exist as a solid, liquid, gas, or even plasma. Now let's look at how matter can be classified. Matter can be classified into a mixture or a pure substance depending on whether its particles can be physically separated or not. So if the particles can be physically separated, then it's a mixture. And a mixture is a substance whereby the substituents or the components are not chemically combined, so each one of them retains its own properties and there is no fixed ratio. Again, we have two types of mixtures. We have homogeneous mixtures and we have heterogeneous mixtures. A pure substance is a substance whose components are chemically combined together, so the particles cannot be physically separated. And we have two types of pure substances. We have compounds and elements. So those are the two types of mixtures. A heterogeneous mixture is a mixture that has a non-uniform composition and its particles are distributed unevenly. We can see how they are. Whereas in a homogeneous mixture, there is a uniform composition and the particles are distributed evenly. Now, let's look at this activity. Over here, we have two beakers and we have copper sulfate over here. We're going to add copper sulfate to beaker A and to beaker B, and we will see what happens. So we're starting by adding copper sulfate, 1 spoon of copper sulfate to beaker A, and we stir it with a stirring rod. And then we add another spoon of copper sulfate to beaker B, and we stir it again. We look at the composition, we can see that we have two clear liquids. We don't see more than one phase. We add again another spoon to beaker B, and we see that even though it's more concentrated, it is still still has a uniform composition. So this looks like a homogeneous mixture, and we cannot see the particles of copper sulfate. Now, if we add iron filings are small pieces of iron powder in the powdered form. If we add iron filings to the beaker of water, we can see how when we stir it, the parts get distributed, but then if we leave it for a while, the parts will settle at the bottom. And this shows that this is, of course, not a uniform composition, and this is not a solution. This is a heterogeneous mixture. Elements and compounds. An element is a pure substance. In other words, an element cannot be broken down into a simpler substance by physical or chemical means. An element is made up of only one kind of atom, and an atom is the fundamental block of matter. So an atom is made up of protons, neutrons, and electrons. Common examples of elements would be carbon, oxygen, and iron. The elements are arranged in the periodic table based on their number of protons. For example, if we look at sodium, it has 11 protons, potassium has 19 protons. The number of protons in an element is always the same. Each element has also a unique set of properties, for example, the melting point over here. A compound is a pure substance of two or more elements chemically combined. Elements combine during a chemical change. A particle of a compound is called a molecule. When elements combine chemically, a new substance is created, and a compound has different properties from the elements that made it. Hydrogen and oxygen are gases. They are diatomic elements whose simplest units are molecules of hydrogen and oxygen. They combine together to form water. Some ions combine to form compounds. For example, sodium and chlorine combine to form salt. Glucose, which is a type of sugar, is made up of carbon, hydrogen, and oxygen. When elements create a compound, they always join in a specific ratio. For example, in water, the ratio is 2 hydrogens to 1 oxygen. If hydrogen and oxygen combine in a different ratio, then they do not form water. We can also see glucose is made up of carbon, hydrogen, and oxygen in the ratio of 6 to 12 to 6. Okay, let's look at those applications. Which of these phrases refers to gases, liquids, and solids? So we know that the particles in a gas are randomly arranged. They can move freely. Particles in a liquid are relatively close to each other, and the particles in a solid are quite close to each other. They have strong forces of attraction between them. The particles in liquids and gases show random motion. What does that mean? Why? And why does it occur? So they have random motion because gases don't have forces of attraction between them. The forces of attraction between liquids is only very weak, and so they have the freedom to move around. Write down two properties of a solid, two of a liquid, and two of a gas, so we can choose any two of each. So solids have a definite shape and definite volume. Liquids have no definite shape and a definite volume. Gases have no definite shape and no definite volume. Number 4, complete the following submicroscopic diagrams to show what magnesium will look like in a solid, liquid, and gas phase. So we know that the particles in a solid are very close to each other. In a liquid, they're a bit far from each other, and in a gas, they're even much farther from each other. So this is how they would look like. Classify each picture as A, element, B, compound, C, mixture of elements, D, mixture of compounds, and E, mixture of elements and compounds. So if we look at one over here, we can see that we have only one type of particles, so this cannot be a mixture. And those particles are made up of more than one type of atom, so this should be a compound. 2, we can see that we have two types of particles, so this is a mixture, and we can see each one is one atom each and different from each other, so this is a mixture of elements. 3, also we can see that we have two types of particles. One of them looks like an element because the two atoms are identical, and the other looks like a compound, so this is a mixture of elements and compounds. Number 4, also we have two types of particles and both are compounds, so this is a mixture of compounds. Then 5, we just have one type of element, so this is an element, and in 6 we have a compound, and you can find the answers over here. We've come to the end of our session. Those are the citations. Take a moment to complete the post-assessment linked below to track your understanding of the lesson. Then complete the worksheets below for extra practice. You can find the answer key in a separate document. Make sure to check out our resource library for additional learning nuggets. Thank you very much for attending the session. Hope you enjoyed it.